Hello everyone, I am Golden Ashwini. I am here to present basics of computer and 8 great ideas in computer architecture. So basics of computer. Actually computer architecture acts as the interface between the hardware and the lowest level software. Computer architecture also refers to attributes of a system visible to programmer like a data type of variables. Attributes that have a direct impact on the execution program like a clock cycle. It is also defined as the study of structure, behavior and design of a computer. So computer organization actually it refers to the operational units and their interconnections that realizes the architectural specifications. It describes the function of and the design of the various unit of digital computer that store and process information. So the attributes in the computer organization refers to control signal, computer or peripheral interface, memory, technology. Then in a computer architecture, it is actually concerned with the structure and behavior of the computer, right? So it includes the information formats in instruction set and techniques for addressing memory. So the attributes in a computer architecture refers to the instruction set, data representations, input output mechanism, then addressing techniques. Okay, now we are going to see about basics of computer systems. In here, the modern days computer systems functional unit is given by von Neumann architecture. Right, so input unit. In the input unit, computer accepts the coded information through input unit. Computer must receive both data and program statements to function properly and must be able to solve problems. So the method of feeding data and programs to the computer is accomplished by an input device. So input devices read data from a source such as magnetic disk and translate that data into electronic impulses for transfer into the CPU. So whenever a key is pressed, the corresponding letter or digit is automatically translated into its corresponding binary code and transmitted over a cable to either the memory or the processor. Next one is CPU, Central Processing Unit. So CPU process data transfer is to from one of the various input devices. If then transfer either an intermediate or final result of the CPU to one or more output devices. A central control section and work areas are required to perform calculations or manipulate data. So the CPU is the computing center of the system. It consists of a control section, an arithmetic logic section and an internal storage section. So each section within the CPU serves a specific function and has a particular relationship with the other section within the CPU. Next is memory unit. It stores the program and data. Memory unit is broadly classified into actually two types. First one is primary and secondary. Primary unit is a fastest memory that operates at electronic speeds. Programs must be stored in a memory while they are being executed. So the memory contains a large number of semiconductor storage cells. So each cell carries one bit of information. The cells are processed in a group of fixed size called words. So to provide easy access to any word in a memory, a distinct address is associated with each word location. So addresses are numbers that identify successive locations. So the number of bits in each word is called the word length. The word length ranges from 16 to 64 bits. So there are three types of primary memory: RAM, cache memory and main memory. Okay, then the next one is arithmetic and logical unit. So most of the computer operations are executed in ALU. The arithmetic logic section performs arithmetic operations such as addition, subtraction, multiplication and division. Through the internet logic capability, it tests various conditions encountered during processing and takes action based on the result. So, data may be transferred back and forth between these two sections several times before processing is completed. So, access time is to register is faster than access time to the fastest catch unit in a memory. So output unit, we know that its function is to send the processed result to the outside world. Then control unit. The operations of the input and output ALU are coordinated by the control unit. So the control unit is a nerve center that send control signals to the other units and senses their states. So the control section directs the flow of traffic and data. It also maintains order within the computer. The control section selects one program statement at a time from the program storage area. So it interprets the statement and sends the appropriate electronic impulses to the arithmetic logic and storage sections so they can carry out the instructions. So the control section does not perform actual processing operations on the data. So the control section instructions that the input device on when to start and stop transferring data to the input storage area. It is also tells the output devices when to start and stop receiving data from the output storage area. Okay, next is great ideas in computer architecture. First one is Moore's law. It is the observation that the number of transistors in a dense integrated circuit doubles about every 2 years. It is an observation and projection of a historical trend and not a physical or natural law. So abstract design, actually it is a major productivity techniques for hardware and software. Abstractions are used to represent the design at different levels of representation. The detailed lower level design details from the higher level. Then the third one is performance through parallelisms. So parallelism execute programs fostered by performing several computations at the same time. So this requires hardware with multiple processing unit. The overall performance of the system is significantly increased by performing operations in parallel. Then the fourth one is performance through pipelining. So pipelining increases the CPU instructions throughput. So throughput is a performance metric which is the number of instructions completed per unit of time. But it does not reduce the execution time of an individual instruction. It increases the execution time of each instruction due to overhead in the pipeline control. So the increase in instruction throughput means that the program runs faster and has lower total execution time. Make the common case fast. So making common case fast will tend to enhance performance better than the optimizing the rare case. So next one is performance via predictions. The computer can perform better by making rational guesses on the decision. Instead of wasting clock cycle for certain result, the computer can remarkably improve the performance. Then hierarchy of memories. So programmers want memory to be fast, large and cheap. So the memory speed is a primary factor is in determining the performance of the system. So the memory capacity limits the size of the problems that can be solved. So architects have found that hierarchy of memories will be a solution for all these issues. So the fastest, smallest and most expensive memory per bit is placed at the top of hierarchy and the slowest, largest and cheapest per bits is at the bottom. So caches gives the illusions that main memory is nearly as fast as the top of the hierarchy and nearly as big and cheap as the bottom of the hierarchy. So dependability via redundancy. So computers need to be fast and dependable. Since any physical devices can fail, we make a system dependable by including redundant components that can take over when a failure occurs and help detect failures. So restoring the state of the system is done by redundancy. Thank you. Thanks for listening.